Continue with our review of quadratic functions, and we're going to look now at how to find the five main features of a quadratic function given in standard form. I'm assuming that this is something that you actually already have seen, so I don't need to explain you why, I just need to remind you how to do it. So let's say we have our function, and I'm going to write just a generic one, so ax squared plus bx plus c. And here I'm going to say that a has to be different than 0, so we are sure that we have a quadratic function. So the first thing we can do is to find what is the concavity. And the concavity is given by the sign of the value a, the coefficient of the term on x squared. If a is greater than 0, then the concavity is positive. And if a is less than 0, then the concavity is negative. So we just need to look at that value to decide whether we are going to have a parabola looking happy, like that one over there, or sad, like that one over there. The second feature we are going to find is the axis of symmetry. The axis of symmetry is a vertical line, so you're going to have equation x equals something, and the something is given by negative b divided by 2a. So we need the coefficient on x squared and the coefficient on x to find the equation of the axis of symmetry. And the axis of symmetry, let me add it in the pictures here, will be a vertical line going through the vertex of the parabola. Well, these pictures are not very good, but you got the point. So, since we know that the axis of symmetry goes to the vertex of the parabola, that means that we know the x-coordinate of the vertex of the parabola. So the vertex is going to have x-coordinate negative b over 2a, and then we're just missing the y-coordinate, so we need to find what is the result of applying the function to the value negative b over 2a. And that's a vertex that, remember, can be a maximum or a minimum, depending on the parabola having negative or positive concavity. To find the y-intercept, that's the easiest. Well, we know how to find the y-intercept of any function because we know the y-intercept is a point to the y-axis, so the x-coordinate is 0, so we need to find what is the value of applying the function to the value 0. And in this case, it's very easy to see that this is 0c. For the x-intercept, we don't need to, but we could use the quadratic formula. We want to know when it's true that ax squared plus bx plus c is equal to 0. This equation, this quadratic equation, can have no real solutions. In that case, we'll be saying that, our parabola won't be touching the x-axis, like the first one I drew here, my example here, not touching the x-axis. It could also happen that we have exactly one real solution. That will be like, for instance, equation y equals x squared, where we touch the x-axis and come back. Or we can have two different real solutions. Like the other example that I didn't draw very prettily over here, but that one over there, the blue one. And we need to find that by applying one way of doing it. Again, that's not the only way, but one way of doing it is applying the quadratic formula. So finding if there exists the values of x as minus b plus minus square root b squared minus 4ac, all of that divided by 2 times a. And we'll talk later about the discriminant, so what is inside the square root over here and how this is what decides in which situation of the 3-1 written over here we are. So that was a very quick review of how to find the 5 main features of a quadratic function given in standard form.